In Python, classes are built into the language, and there is only one way to use them. In JavaScript, they are not built in. You only get the tools to make your own classes. And there are several different ways you can make them. If you go to the Douglas Crockford's website, he has very nice articles about different ways you can implement different kinds of inheritance in JavaScript. That's very interesting. But here we will just talk about the way that looks the most like in Python, so that you can just jump into that with your Python knowledge. As you remember, every object that you create can have a parent. Those parents act as if they were superclasses of the object. In Python, you have a distinction in class instances. So you have classes and you have objects. And here is an example code in Python that creates a class and then creates an instance. Okay, let's make it a little bigger. Creates an instance of that class and calls a method on that. Right? And in JavaScript, what we would do, we would make one object that has all those things that we defined, and then instead of creating an instance of that class, we would make another object that has this initial object as the parent. Actually, our initial object also will have a parent, but it will be an empty object. So this base thing is like this object here. This point thing will be like this point. And later we will see how we create it. So we use our create function that we have defined at the very beginning, and in a moment I will explain what this create function exactly does, so that you can understand how new works. But right now, just remember that it creates an object that has the parameter as the parent. So we create an object that has empty object as the parent, and later we monkey patch that object to add the init function to it and the move function. Then we will make a constructor function, so that we can call it like we do in Python. Just the name of the class and then parentheses. And it will return the instance of our point. So it again will create the instance with point set as the parent, and then call the init function of it. You can think of it like the new function in Python, the new function. Okay, if we wanted to make a more universal function like this, instead of having a fixed set of arguments here, we would instead use apply, something like this. Init apply on the instance and arguments. This way we can change the list of arguments of our init function without having to change the constructor. This can be omitted at first reading. When we have this object, we would like to have a nicer string representation. Because right now, when we make an object and we try to get a string of it, we will get object, and that's hardly useful. And if we have some point class that we would like to use and we would like to, for example, debug our program and see what point it actually is, we would like to have something printed here about the x and y of the point, right? Maybe something like this. So we can create a toString function, and because we don't want to do it for every possible object that we are making separately, we can put it on the base object, on this empty object that we started with. This way, if we always use base for creating our classes, we will inherit this toString function, and we don't have to rewrite it. And it will use the class name attribute of the object on which it is called, but there is no such attribute in JavaScript by default. We will have to set it ourselves when we are creating our class. So later we will see a complete example of such a class with the name set on it and stuff like that. So this is not a built-in mechanism of JavaScript. We are making this manually. Okay. Constructor factory. You can see that this point constructor that we have here, we will need a similar constructor for every class that we make, right? Because that's the way we are going to use those classes. And it will have the same code in every one of them. And we don't want to copy and paste blindly the same code all over our sources, because that just invites mistakes and makes it harder to read. So we will have a factory function. A factory pattern is often used when you need to create different objects or different functions depending on some parameters. In this case, the parameter is the actual parent we want to use, and well, the parent, the class that we want constructor for. So, and our factory will return a function that is the constructor for this particular class. It's actually pretty straightforward, but it's worth noting that it is using a closure. You see, because it creates a function instead of inside the function, there is an error here. Again, there should be a function, an equals and a function keyword here. This line should look like this. Right. There is a mistake Anyway, it creates a function that uses the parent argument from the outer scope. Okay, I will explain about closures. That's the wrong one. Sorry about that. I got kind of lost. Core JavaScript build. Okay. Okay, there are three basic reasons why you need closures in JavaScript. The first and foremost is the fact that this only gets set when you call the function. So anytime you want to pass around a method that remembers which object it belongs to, you have to wrap it in a closure. In that closure, you keep the reference to the object. We will see that pattern in a moment. Well, this is closely related, but if you are passing a callback function to some event, or passing it to some factory function or something like that, you can create a function at runtime with a closure in it to pass some additional variables from your current scope into that callback. And yeah, that's basically point 2 and 3. We can see how a closure works. It's actually the same as in Python. So let's see. Let's say I'm defining a function. Okay, without parameters. And inside that function, I will define another function. Function. This is the same thing that we saw with the setters and getters. We have some function, and inside that function, in the function scope, we have a variable. Then we have, okay, I have to return that function. Otherwise I don't have any access to it. As you can see, I'm often forgetting the semicolon. This is very wrong, because again the result of forgetting a semicolon depends on what browser is used. Okay. If we call that function, we will get the G in G back, and if we call it, it will return the A variable from inside the F function. We can use that pattern to have our methods bound to the objects. So for example, if I make we will use this getThis function that I have defined before. If you don't remember it, it looks like this. Oh, okay. I can show. I can show you by defining it again. Yeah, it looks like this. And it returns whatever this is in the scope. So we will assign it to the object, and if we call it normally, it's fine. We get our O object. But suppose you want to pass it as some argument to some function or save it as a callback somewhere. So we will do this x and call it like this. We get the global object instead of O. That's wrong. We don't want that. So instead of doing that, we will do this. Then if we get the right result. So we basically wrap our function into a function, into another function. So we still have this O.f thing in here, so that this gets set to the right thing. Actually, if we want to make it more robust, we actually would do that like this. So we can call it with arguments, right? Whatever arguments we pass to xxx will get passed to this f. Why does it return a function? Oh, because this is the wrong f. Right. Now it works perfectly. And this thing we are doing here is called binding. We are binding the method to the object. So now when we call it, it will always get called on the right object. And the way it knows the object is because it has a variable from the outer scope. We can have and we will have a bind function that actually let us do it a little more. It will be a function factorial. We would like to, instead of having to write something like that, we will write something like that. Bind, what? Yes?
So if it's not good answering at that point, you might postpone it, but just wanted to ask here. I think it had happened 2 or 3 times now that you said, oh, well, in principle we need a function for that and it should come from some kind of framework. Is there some general advice you could give now, like, okay, store this and this and this to a file and import it every time, or use this framework, it's lightweight and you have all that? So
usually you want to adapt to whatever your project already uses. They usually have the same set of tools you can use. And if you use things like CoffeeScript, for example, they have this built-in into the language. Because CoffeeScript is kind of language nicer than JavaScript that compiles to JavaScript. So it generates JavaScript that does the same thing, kind of. And they have this built into the language. And every framework, every larger framework that you will use has something like that. The advice is to always do what the framework does, because you don't want to fight with the framework, and you don't want to confuse the other people who are going to use that. So I'm showing you how those things work, but usually you will not have to write them themselves.
Yeah, thanks.
Bind. Okay, I will show you how we want to be able to write something like that, or maybe the other way around too. So we bind this function to this object, and to do that, we have our function, we have our object. We will want to return a function. That function should call the function, the func that we got, with the object as the parent, as this, and the arguments that we have passed to it. Okay, so now when we do this, and we call it, we have undefined. Why is O of F undefined? Oh, right, there is a syntax error. As usual, JavaScript helpfully doesn't show you any error messages. Now it works fine. So, to look again at this bind thing, it's a factory function that... Go back. Okay. It's a factory function. So it takes some arguments and creates something for us. It creates a function. That function in turn just calls whatever argument was the first, calls apply on it with the object that we have passed, and the same arguments that were passed to this function. Right? And both the func and obj variables are taken from the outer scope, so they live in a closure here. Because the scope of this outer function lives forever as long as we have this inner function somewhere. Okay, so bind is a very useful thing, and that's one of the most common things you use closures in JavaScript. There is a pattern where you can use closures to make private variables for your classes that are not in any way accessible outside. But since we are here in JavaScript for Python programmers, and Python doesn't have private classes, private methods, and private attributes, we won't go into that. We don't need them. Just make everything public. We are consenting adults here. Okay. So that's it. And okay, let's try to make the point class in JavaScript so we can get a feel. So everybody try to type it in your consoles too. Okay, we will make our base object that we will always inherit from. And we will need our create function. It takes the parent as its argument, and it will need to create an object using new that has the parent set as its parent. Okay, so the people who designed JavaScript, it was a political thing. Java was a new thing back then, and Netscape wanted to kind of relate to that. And he said, okay, they said, okay, make it look like Java code. So the guy, okay, how do I make it look like Java code if there are no classes? So, okay, think of something. So they thought of something like that. In JavaScript, you are supposed to make your object. That's me stepping on it. Yeah. I will try not to walk so much here. Sorry. And they thought, okay, so let's make it like this. You make a function that is the constructor. Var constructor for your object. So it may be your point. And it will be a function that takes the arguments, and what it does is initialize those arguments, right? And then when you want to have some base class, just set prototype to that class. Now, when you actually want to have an instance of your class, you do this.
Yes. Pointer prototype equals to base. What you just type means that the class point will inherit from the so-called class?
No, it only means that we set a prototype, an attribute on this class.
Oh, it's just an attribute.
It's just an attribute, but it's a special attribute that's used by new. Because you cannot just tell new, okay, create me a new object with this as the parent. It will just take your function and take the prototype attribute from it and use that. That's what they do to make it look like this, because this was the goal. Make it look like in Java.
Okay, thank you.
This is what the authors of JavaScript had in mind when they invented the language, that you should do this thing in this way. But later on, people started to use it, and they discovered that it's not very the most useful way you can do that. So we will make a create function. All the create function does is encapsulates this logic so that we don't need to use the new keyword. It basically takes it will take this base and create a new object with this base as the parent. So goes like this: create parent. Okay, we will need a function. So let's make temp, or let's call it constructor or whatever. And this function doesn't do anything. We don't care what it does. Now, constructor dot prototype equals parent, and return new constructor. And
you have created the empty function outside in GS, in counter.js it's outside the function. Does it matter? You make a global create underscore fn. I'm referencing to the counter.js.
Wait. Let me look at what I have done. Oh, that's wrong. Right. Thank you. Of course, this should be var create equals function. Thank you, JavaScript, for not telling me. That's why you need JSLint. JSLint will tell you. Okay, then now we have the create function. And let's try to create something. Let's create our point. Constructor not defined, because I made a typo. Constructor. Ta-da! We have a point. Prototype. Okay, we can change that. Check it like that. And actually, now if you add something to the base, like the toString method, or just some name, that's enough, and we try to access it on point, we have it. So we have our create. Now we want to have a similar system to how Python works. So because this is kind of simplistic, right? We really want our classes and our objects separate. So what we do, we will make a lowercase point for our prototype, and we will make a uppercase point that takes some x and y, and it's basically a constructor for our point. So it takes and creates something that inherits from our prototype, and then it will call init on it. Not point, but instance. And here we need apply. Sorry. Instance, init, apply, instance, arguments. Okay, and then we return it. Now, we don't want to make this for every single object that we define, so we will make a constructor factory. Well, we can see that if we make this point, we don't have init. Okay, let's take our point prototype and add init to it. It takes x and y and sets x to x and y to y. Ta-da! So it behaves almost like in Python. Now we don't we don't want to have to write those functions by hand every time. So we'll make this make constructor thing. So make constructor, and it will be a function, and it will take the parent as argument, and now it will return another function. And that function has to do what this point function does. So it will make an instance, create parent, then it will call init on it. Then we'll return it. Then we are done. Okay. But now we can make this like this. Okay, so suppose we want a rectangle. So we have all those functions already, so we can make it pretty fast. So let's make a rectangle prototype. We inherit from our base. It's an empty object. You could call it object if it wasn't a reserved name in JavaScript. Okay, we have rectangle. now rectangle init. It has top left, top left, and width and height. Right. And it is a function. This x is x, this y is y, this width is width, and this height is height. And now we make rectangle, make constructor of rectangle. Constructor. Excellent. And we can make a rectangle. Rectangle. 1, 2, 3, 4. Ta-da! You may be concerned that the name lowercase rectangle is already taken and now you cannot use it for instances of rectangle. But usually you define your prototype in a different scope that you use the function. Usually you only use this in other parts of your code, right? So it doesn't hurt to have this variable used. Of course, every time I'm defining some variable here, I'm defining it as global. Don't do this in your programs. In your programs you want them all to be local. So when you are making your program, you usually start with something like this. Then you put all your program here. Then you call that function, and that's your program. This way you create a new namespace and put everything you need in that namespace, and nothing, when it finishes running, nothing is left in the global scope. If everybody does like this with their scripts, you don't have strange effects of having one script affect another script. So this is if you do script in your HTML file, you include, for example, Google Analytics, and suddenly your program stops working. You don't want that. So it's a good pattern. And also, you can do something like this. Suppose you are using jQuery, right? So you can do something like that. This calls this function. Okay. It calls this function with this argument. And this argument becomes the dollar. By the way, dollar is a valid variable name in JavaScript. You can have dollar in anywhere in your variable names. Initially, it was meant for some special use case for debugging or assembly or something like that. But nowadays, it's used by frameworks. And for example, jQuery has it. Uses it as its main object. And if you have several frameworks that use the dollar sign, and you want to use one of them in one script and another in another, then you can have them as normal names, but inside your code use dollar, because this dollar will be defined only here, only inside your code, right? And if you want this code to actually return something, because, for example, you want to have a rectangle class, like we just did, but you don't want the name lowercase rectangle to pollute your namespace. You do this stuff that we did before, etc., etc., and then you do. Actually, I did it wrong. So you do it. Yeah. Rectangle is make constructor. Yeah. And return rectangle. Yeah. Then you have it encapsulated, and only the uppercase rectangle variable is available from the outside. Okay, then we know how to make classes and how to make them behave like in Python. Let me check what else we have in the agenda, because I don't remember. And delegation, and to review our example again. Okay. So delegation is kind of a high-level concept, again a programming pattern, and I think we will actually see it in this counters example, because it's a piece of code that we can have. Okay. If you look at this onClick method that we have here. Oh, that doesn't scale well. Nope, nope, nope. Exercises. Counters example. Here. Okay. So we have an onClick factory that takes a list of models that we have defined previously, and for each one of them makes an event handler. The event handler takes the event object as a parameter, except that for Internet Explorer it takes a global event variable. So we have this, either we take event or event from the global namespace. If you do any browser JavaScript, you have to do tricks like that all the time, or just use a framework that does them for you. That's the best thing. And again, the target of the event is either event.target or event.src element, depending on the browser. This is OR. It doesn't. JavaScript has those C-like operators, not the nice English operators like in Python, unfortunately. But it's normal. It behaves like OR in Python. So it takes whatever of those elements is not null or undefined or truthy. Okay, and we have ID of the element. And if that ID actually exists, remember that if there is no attribute ID on the target, we just get undefined. We don't get an error. This construction is another idiom for Java. You remember that JavaScript does automatic conversion. So to convert anything to string, you do something like this. And to convert anything to a number, you do this. Yeah, it's not a number, so it returns not a number. Again, this is very, very nice, because not a number is not equal to not a number. Never. It's not equal to anything. And it makes it a little tricky to check if it's not a number. You know, to check it, you'll get something from the user. You convert it into a number, and you want to raise an error or something like that if it's not a valid number. And you cannot just write something like that, even if there was none as a... Actually, there should be rectangle. Okay, and none. Yeah, it's false, even though we know that it's none, because none is not equal to none. And that's actually correct. It's the same in Python. It's the same in any language that uses this IEE standard for floating point numbers. That's actually by definition. And there is this is none function, especially for this purpose. So this is a little trick. Okay, so the trick here is this plus. Instead of plus, you could also write this, right? This is the unary plus. It's like a sign of the number, right? And so you could just use two minuses, except that. Let me just try something. Yep, you cannot use two minuses. Thanks. Because but you could do this. Oh, that works. Anyways, plus works as well. So let's use plus. So here we basically ID is a string. We slice it to remove the first character, and we turn it into a number. Because JavaScript doesn't have int and float separate types, everything is a number, and the number is a float. You don't have ints. Okay. And then we look up it in the models, and we call the onClick method on that model. That's the whole idea. We delegate the behavior of our function to something that is defined on something else. This way we can have different models that do completely different things depending on what is actually on them defined. Actually, this is not as deep as it seems. It's a simple idea. So if we only have counters here. So the onClick on the counters only increments them. But we could have a different kind of counter that decrements the counter. Or we could have, I don't know, a bomb that blows up when you click on it. And with this kind of on-click handler, we do some initial processing. Basically, we find which models we want, and then just delegate the rest of the work to the method on the model. Similar, we get the HTML that we want to put on the page from the model itself. We don't generate it here, we take it from the model, and then we just replace it. If we look at the model that we have, it's our counter, right? And we have the on-click here. It basically increments the count, and the HTML here, it basically displays the count. We could have, I don't know, the bomb model would probably give you some HTML that has some CSS animations that make it blow up or something like that. That's the idea behind delegation. And okay, now we use this delegation because we connect this on-click event not on the, in our HTML, we connect this on-click on this div, on this example div. So in the actual example that I don't have open and I don't want to look for now, so in the actual example, when you click on something, the small boxes don't have on-click on them. So the browser goes to the next element, and next, and next, and then fills the first element that has on-click event on it, and calls that. And then we go lower. We actually have to find the target which was clicked, to find out which of our models was clicked. Then we can call the right one. Instead of doing that, well, it's done like that here for educational purposes. Normally you would put the on-click event directly on this counter box and just use closures to make sure that the right box is incremented, right? You would use this bind thing to make sure that the function goes to the right object, and for every of them different. Okay, there is one more thing here at the end. This element equals undefined. So JavaScript has garbage collector, so you don't have to care about memory management, except because it basically keeps track of, once in a while it checks for objects that are not referenced anymore and frees them. But there is a special case when you have two objects that have references to each other, right? Because they would keep each other alive for eternity. And when you don't have any other references to them, you would like them to be freed to free the memory. And the JavaScript garbage collector does that. It can find the cycles. There are complicated algorithms that do that. The designers of the language did a great job with that. There is one small problem with IE, with Internet Explorer. So Internet Explorer has two pools of memory. There is memory for the JavaScript objects, and there is memory for the HTML elements. and both of them have separate garbage collectors. So if you have two JavaScript objects that have references to each other, the garbage collector will find that, oh, there is a cycle here. Okay, I can throw this all away. And if you have two HTML elements and they have references to each other but not references from outside, it also works fine. But if you have one JavaScript object and one HTML element and they have references to each other, then each of the garbage collectors think, oh, I cannot throw this away. There is a reference from the outside. And the other things, oh, I cannot throw this away. So you have a memory leak. You have some objects that you don't need anymore that sit in the memory. That's why you have to close the Internet Explorer once a day or once a couple of days, unless unless you do that, it will eat all the memory that you have. But there is a method to avoid that. Every time you look up some element with getElement by ID, and you finish doing anything you did with that element, free it explicitly. Just assign something else than that element to this variable. That will make sure that Internet Explorer, okay, there are no references anymore, I can free that. That's how it works. It gets a little bit more complicated if you have closures, because as you remember, closures are kept in memory forever. So, and there are two very bad cases. So, JavaScript has this timer thing. So you can write something like this. And set timer, timeout, sorry. Yeah, and after 1 second, well, make it 10 seconds. No, it works. Okay, but there you can see that I passed a function here. You could as well do this, right? And why you shouldn't? Anywhere, you can also do similar thing with exec, right? Oh, nice, something completely broke. You can do exec. Or maybe not. Well, maybe there is no exec in Node.js. Anyways, whenever you use a string for your code, like in this set timeout, it's as if you are defining a function in place, and it doesn't know which variables from all the scopes over you it will need until it executes it. So it has no idea which variables you are using, so it has to assume that you are using all of them, and it will keep a reference to all of the variables that are available in that place. That means a huge memory leak, because it will take every variable that is available at this point. it doesn't know what's inside the string until it tries to execute it. So it has to keep everything in memory. Don't do that. Define a function and call that function. If it has a function defined, it can look inside the function and see what variables are used, and rely on that. So this is another source of memory leaks. And let's see what we have left. Oh, the JavaScript and Python objects and classes. So this is something that Jonathan found out. And if you have a Python class, it also has kind of prototype thing. There's the super class, right? And we can make the Python class behave like JavaScript object. Basically, we need to define those get item and set item to do the same thing as get at and set at. And we need to change the way the classes are created to allow us to inherit from other classes directly. And Jonathan does it with a meta class. I don't feel I can explain what meta classes do right now in Python. They are a very interesting topic, and surely you will want to explore that. But I don't really feel competent enough to explain this to you now. So I think we will leave it at that. So thank you very much. And if you have any questions now, ask them or be silent forever. Or
So any questions? It's okay. Oh, one?
A small remark, just this whole talk about how to turn JavaScript to behave like Python, like how we think a programming language should behave, made me think, do you think JavaScript programmers do the same thing, like how to turn Python into the horrible silent casting integers plus string equal not a number thing? Or are they happy with Python anyway?
I don't have that much experience with JavaScript programmers, because they are kind of rare, and usually your first language is not JavaScript, although it is changing. But I have some experience with PHP programmers, and PHP has a similar philosophy of not giving you errors for anything. It has this beautiful add operator that lets you do this and don't care if it's succeeded or not. Ignore all errors. It's great. And I know that PHP developers do try to make Python not complain about everything. It's a usual question. If there is a non-strict mode for Python, for example, and things like that. So I think hardcore JavaScript programmers would also could want that, but the tendency in modern JavaScript is generally to do everything to avoid this behavior of JavaScript. So there is this strict mode now in ECMAScript, in the new version of the language, where you can put the string strict at the top of your program, and then it will complain about missing variables. It will complain about attribute access, I think. I'm not sure. I don't want to lie to you. But it will be much more, how do you say, complaining.
Strict.
Yeah. Yeah, and it's recommended that users use strict. So I think that the JavaScript culture actually recognizes that it's not good to ignore all those errors.
I'm really impressed because that was a hugely trolling question and you managed to avoid the troll and give such educated answers, so thank you very much.
Thank you.
Okay. Thank you very much for this training. So,
Yeah,
there is
thank you.
sorry. Is there anyone more questions? Oh, sorry. There is another one. Yeah.
Great. That means you were watching.
That's okay. Do you know of any resources? Now, I'll be specific. I have a minimal knowledge of JavaScript. I've learned some things today. And what I've noticed is on the web there are thousands of websites that offer lots of scripts themselves as well as tutorials. This is an interesting talk today, thank you. Is there a online resource that perhaps phrases it positively? In other words, here's a good way to write JavaScript. You know, since you're, for a programmer who will want to write something for a web page.
Yeah. Okay.
Good examples.
So
Thanks.
Douglas Crockford is your go-to man, as usual, and there are two resources. I already mentioned the book, JavaScript: The Good Parts. It's really thin, so you can go through it fast. But not everybody likes books. I don't like learning from books. I prefer to go on the internet and learn from the web pages and from the documentation. Somehow it's more convenient. So myself, of course I was using JavaScript before, but at some point I decided, okay, it's time to actually learn the language and to start using it properly. And then somebody recommended me the videos of a JavaScript tutorial that Douglas Crockford did on Yahoo when he was working at Yahoo. And I think it's on Yahoo Video, and if you search for Douglas Crockford JS or something like that, it's about 4 hours total. So it's about the same length as this tutorial was, but he really goes into small details of the language, and you can really learn from it pretty nicely. And of course, look at other people's code. Just choose carefully. Because there is a lot of bad code. Don't go to W3 schools. That's the worst website for learning that ever was, and I'm not afraid to say it. They can sue me. I don't care.
Okay, anyone else? Okay. Okay. So this time's for it. Thank you very much.
Thank you.
So I think there is one last presentation in the big room from Lindruth, if I'm correct, and I guess you don't want to miss it. Okay. Thank you everybody for being here in the training session.